So this is section 1.3. Our objectives for today are to build the right equations of linear functions using points and slope, and then find lines of fit and lines of best fit. So a lot of you've done this in Algebra 1 already. Most of what we're going to do today will be a little bit different. So writing an equation of a line. So remember a line, if you go back, that's slope-intercept form. Y equals mx plus b. That gives us a linear line equation, which we'll be writing today. So the first type we're going to be doing is if we're given the slope and we're given the y-intercept to start with. Well, that's pretty easy because we can just use slope-intercept form. So they'll tell you things like slope equals 3, y-intercept equals -2, and then you just plug it in. Y equals 3x minus 2, and you're done. So really easy when they're in that form. The next thing we're going to do is given the slope and a point. So now they tell you m equals, let's say, -2, and it passes through the point. Let's go for -5. So there's a couple ways you can do this. The easiest way is to use point-slope form. But let me go through how you did this in Algebra 1. In Algebra 1, you would have done this. You would have taken the equation y equals mx plus b. You would have plugged in the slope, and you would have plugged these values in, because remember your first one's x and your second one's y, and you would have said -5 equals -2 times 4 plus b, and then you would solve for b. So this would be -5 equals -8 plus b. You would have added 8 to both sides and gotten 3 equals b, and then have been able to write your equation y equals -2x plus 3, and you'd be done. So that's probably the way you did it in Algebra 1. Point slope form is just another equation for a line. So let's take this and do the same thing. So we take our y minus y1, and our y1 is from our ordered pair, so -5. So since it's minus a -5, I can plug it in this way, or I can just change it to y plus 5 because of the double negative. Y plus 5 equals m, which we know is -2, x minus x1, which is our x value. And you can just leave it like that because they don't ask you to put it in slope-intercept form. So that's the equation for the line, and it works. But if I wanted to simplify this, okay, if I multiply this through, I get -2x plus 8. And then I would subtract 8. Actually, I can just subtract the 5. And I get y equals -2x plus 3. So you can see we got the same answer both ways. It's just nice for graphing purposes to have it in slope-intercept form, but when they just ask you to write an equation, it's really easy just to put your final answer in the form of this, and there's really no work to do. You just plug in the values for the slope and the points for x and the point for y, and you're done. You can just leave it like that. But either way works, so you have your choice on that, up to you. Then, the other thing we're going to be doing is given 2 points, write the equation for the line. So let's say I'm given the point 3, 7, and -2, -5. And now we have to write the equation for the line. So, the first thing we have to do is find the slope. So remember, for finding the slope of 2 ordered pairs, use the equation y2 minus y1 over x2 minus x1. So in this case, again, it doesn't make any difference which one you call the first set and which one you call the second. I can call this x1 and then this would be y1, and then this would be x2, and this would be y2. Or I could call this one x1, but then that makes this y1, and then this is x2, and this is y2. You'll get the same answer either way, so it's totally up to you. In fact, let's just show this both ways. So I'm going to call this the second set. So that would be negative 5 minus a negative 2 over, negative 5 minus 7 over negative 2 minus 3. So in this case I get negative 12, and in this case I get negative 5, and 2 negatives gives you a positive, so that would be a slope of 12/5. If I would have done it the other way, let's call this one the second set. So that would be 7 minus a negative 5 over 3 minus a negative 2. And so again, that minus a negative 5 becomes plus a positive 5, so I get 12. And the minus a negative 2 becomes, so I get 12/5, which you can see is the same. Once you find your slope, so we found the slope, then I have my choice. I can do it where I plug this in for the slope and solve for, and use one of the ordered pairs. And I can use y equals mx plus b. So I could plug that in for m and then use either one of those ordered pairs for x and y and write my equation and solve for b. But the easiest way again is to use point slope. So I'm just going to go y minus, and so now I have my choice which one I use. I can use the 3, 7, so that would be y minus 7 equals 12/5 x minus x1, which would be 3. Or I could have gone y plus 5, sorry, because it's minus a negative 5, so I could have gone y plus 5. Y plus 5 equals, again, 12/5 x, and then minus, I went minus a negative 2, which would become plus 2. So both of these, if I simplify them, would end up just like when I did this. But you can see it's a lot less work than if I had to go up here and go plug in, let's go 7 equals 12/5 times 3 plus b, and I solve that for b. I get the equation, but you can just leave them in point slope form, and they'll say ask you to switch it to slope-intercept form. So that's the first part of the assignment. We have to do 3 things. We have to be given the slope of the y-intercept, write the equation. So they give you the slope, and they give you the y-intercept, and you plug it in, and you're done. That's easy. Given the slope at a point, again, easiest way is to use slope-intercept form, because again, it's just plugging it in. There's no math to do. And the last one, there's a little bit of work to do because you have to find the slope first, but then again, you can use point slope form, and one of the 2 points to write your equation. So that's the first part of the assignment. So if we go to page 22, number 1, because some of these you're going to have story problems on. It says the graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of the line and interpret the slope. Now when I ask you to interpret the slope, that just means tell us what the slope means. So the asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? So we take our points here, and so we've got the point. It says from the graph you can see that the slope m is 24/5 because they're taking the point 0, 0, and 5, 24, and they're finding the slope, which would be, again, you could use y2 minus y1 over x2 minus x1, or in this case you can just say it's up 24 and over 5 because it's rise over run, and so our slope is 24/5, which they switch to a decimal. It doesn't make any difference which you leave it in. Our y-intercept is 0, so we know our b, So they plug it in, and our value is y equals 4.8x. Hello. Then we have to write now that we've got the equation, we can substitute the values in. So it says the slope indicates that the asteroid travels 4.8 seconds per mile. Use the equation to find out how long it takes the asteroid to travel 17,200 miles, which is our y value. And so now we're back to a basic Algebra 1. We divide by 4.8, and in this case it's approximately 3,583 for our x value, which is our time. All right, example number 2, another story problem. It says 2 prom venues charge a rental fee plus a fee per student. The table shows the total cost of different numbers of students at Lakeside Inn. So this is the table we're going to have to use on this. And it says the total cost in y dollars for x students at Sunview Resort is represented by the equation y equals 10x plus 600. So what you have to do sometimes when you're looking at prices between more than one company is you have to look, because they can set those rates and it might be cheaper to go with one company depending on the number that you're buying. So when we look at this, it says which venue charges less per student. Well, the per student charge comes in the slope. So in this case, this one's charging $10 for the fee and then $600 up front. So it's $600 no matter how many kids are there, and then $10 per student. So what we have to do is take this one and find out what it charges. And so again, it's the same type of thing we just went through. So you can see here that they went through and they picked 2 points on here. They put 100 and 1,500, because 100 students would cost $1,500. And then they chose the one that was 125, and for 125 they charge $1,800. And so when you go through and you plug it in, you get that 300 divided by 25 is 12. Well, that's your slope again, and that's the price per student. So we can simplify this out, and you can see that this one has an initial fee of $300, but then it's going to charge $12 per student. So now we know the cost. Now the thing to do is to look and see which one's the better deal. Well, it all depends on how many students you're taking. This one, it's 300, so as long as our students is a certain amount, it's going to cost less than the other company. And so now what we do is we set them equal to each other. So they took the equation for the one company, which was 10x plus 600, and then they took the equation for the next one, and they solved this. So on this, what they did is they subtracted 300 from both sides. And they got and they subtracted the 10x from both sides. And they got 300 equals 2x. So that tells us that at 150 people, the 150 is going to cost the same amount no matter which company you use. So it wouldn't make any difference. But less than 150, it's going to be cheaper than with the company that charges $12 per person, whereas the other company would be less once you get above 150. So you have to look at those and see which one's going to be the best deal. Then it says, comparing the slopes of the equations, you can see that Sun River charges $10 per student, which is less than $12 per student Lakeside Inn charges. The total costs are the same when you get to 150 students. So notice that the table shows now the total cost of 150 students at Lakeside is $2,100. So it would be $2,100 for both of them. And you can check this, but it's just a way to compare the two. So don't always go by, oh, this one only has a $300 initial fee, where this one's charging twice as much for an initial fee. Again, it depends on the cost per item. You see this like when you do, like if you're screen printing t-shirts, you know, they have a setup fee and then a cost per shirt, and so you always have to compare those to see which is actually going to be the better deal. So if we go back to the notes, now the next thing we're going to do is finding a line of fit. Not everything fits into a straight line when you get the data. So sometimes you have to find that line of best fit. And the line of fit is just, let's say I've got a graph. And I want to find a linear line that gives me an estimate of that data. Well, there's a little bit of work to do. We can do it on our own. Create a scatter plot of the data, which is what we have here. Once we have that scatter plot, you sketch a line that most closely appears to follow the trend. So this is going up to the right, and what you want to kind of do is get half the data above and below that line. So I might take like, let's say, this point and this point, and draw a line through that. And I've got about half the data above and half the data below. And then I could use those 2 points, whatever those ordered pairs are. Let's say it's 7, 5, and let's say it's 12, 10. And I could go through like we did before, and I could find the slope, and I could find the y-intercept, and I could draw that graph. So, given by the data points, and again, you want about half above and half below the line. Then, choose 2 points on the line and estimate the coordinates, which we've done. And then write an equation of the 2 points. And this equation is a model of the equation. So again, we can take those 2 points, we can find the slope, we can put it in point slope form or slope intercept form to get an equation for the line. And you'd be done. Okay? And that would give you an estimate. And it's a rough estimate because everybody could pick different numbers. There might be more than 2 points that are going to give you an accurate, or you might pick wrong. So the question becomes, how can we get an accurate line of best fit? So if we go to the next page, the line of best fit is the line that lies as close as possible to all of the data points. And we have what's called the correlation coefficient, which is R, and you'll see that in a minute. And that is a number from -1 to 1. That measures how well the line fits the data. If it's exactly a linear line going up, it would be 1, and if it's exactly a linear line going down to go to the right, the slope, it would be a -1. So, like, if I get R is 0.97, then I know my graph is pretty accurate. The same thing if my R is -0.95. Okay? The closer it gets to 0, the farther off your data is, and the less accurate your line is at best fit. So if I get an R equals 0.15, that means there's a lot of data off that line. It's not, the data is not real close together, but we still have a line of best fit. So the closer, the nearer you are to 0, the points do not lie near the line. Okay? So if it's near 1, then the line lies close and is a positive slope. If R is near -1, then the line lies close to all the points and is a negative slope. And if R is near 0, then the points do not lie near the line. So an example of this one would be the data is pretty tight together and it's going up. This one would be the data is pretty close together, but it's going down. As we get near 0, that would tell us that maybe we have our data spread out, so as I draw this line, that we got a lot of points that are a long way from the line. Whereas here, when I draw this in, they're all really close to that line. But here, even though I might have a line of best fit, the data is all over the place in accordance with that line. And we can do this on the graphing calculator. So, if you have a TI graphing calculator, to find the line of best fit, this is the steps you go through. So any of you that are using the TI calculators, you're going to go through these steps. And so you can just write these down if you're doing it and take it through. If you have any trouble at all, let me know and I can help you with that. Again, most of us are going to be using the Desmos calculator. The Desmos calculator is really easy, and I can show you this. But the first thing you do is enter the table of values. Then you enter the equation, y1 equals mx plus b, and then the calculator gives you the values for the slope and the y-intercept. So if we go to the Desmos, which I'll show you. So I did one of these for you. I just typed in the values, 2, 5, 3, 7, 4, 8. To do that, let's go back. Let's add another one here. If we're going to add a third equation, all you do is you go to here and you hit table, and it gives you a table so you can type that data in. So you just put in your x values and your y values, and you go from there. But so I've typed in these values. I get that, and then I just type in the equation. So let me just show you this. I type in the equation y, and the subscript 1, it goes there automatically when you type it in. And then the weighty line is for approximately, and that's right here. So y1 is approximately m. And then we go to x1. And again, it will put the subscript in. And then we put plus b. So we just type in our line for a slope-intercept form. And the reason we're using the y1 and x1 is because that's what's up in our chart. If you enter another one, you might get it showing up as y2, x2 and y2, then you'd have to change your equation. So whatever the table has these labeled as subscripts, those are the numbers you have to put into this equation. But you can see it tells you r squared, and then it tells you the r value, which is 0.8683. So that's fairly accurate to a linear line. It's close. And then it tells us that the slope is 4.4, and that the y-intercept is negative 6.4, so I can write my equation. And I'm done. So you can see you can quickly get an equation if you have a set of data and find out what that is. And again, how close it is to 1 or negative 1 tells you the accuracy of that. So that's the assignment for today. And that's on page 26, numbers 1 to 25, the odds. And again, that will be on the Big Ideas Math, and it'll be on there for you.